Hello, here I'm going to work out two problems from section 1.6. I'm going to do the radical equation and I'm going to do the rational equation. So this is taken from number 38 on page 128 in your textbook. So if you want to follow along or look at some other examples like that, you can. All right, so let me get started. So the first thing we want to do is, as we are trying to get rid of this square root here, you want to isolate the radical. So in order to isolate the radical, you're going to add 3 to both sides. So once you add 3 to both sides, you end up getting 2x plus 3 equals square root negative 5x plus 24. Then once you get that radical isolated, you're going to square both sides in order to get rid of the square root. On the right side, you are going to extract that square root and just get what's left on the inside, negative 5x plus 24. And on the left side, once you expand that out, you end up getting 4x squared plus 12x plus 9. So you remember the 2x, or anytime you have a parentheses square, it just means to do it twice and go ahead and distribute. All right, so now that we have this, we want to set it equal to 0. So you're going to add 5x and you're going to subtract 24. And you're going to end up getting 4x squared plus 17x minus 15 equals 0. So just looking at this, I can't tell that it's factorable. So what you can do is go ahead and find the discriminant. So if you find the discriminant, that's the inside part of the quadratic formula, inside the radical. Solving for that will help you determine if you have something that's factorable or not. So if you plug everything in, you end up getting 17 squared minus 4 times 4 times negative 15. This number is 529. If this is a perfect square, that means that my equation is factorable. If it is not, that means I just continue with my quadratic formula, which I already have my b squared minus 4ac figured out already. So if you take the square root of 529, you end up getting 23. So that means this equation is factorable since our discriminant was a perfect square. So if I wanted to factor this, I'm going to use my AC method by multiplying 4 times negative 15. That gives you negative 60. I would like two factors of negative 60 that also add to give me 17, which is my B number in my equation. So figuring out some numbers, 20 times 3 gives you 60, but I wanted to make the 20, oh, excuse me, I wanted to make the want to make sure I'm doing this right now. So we wanted to make sure, I think I used, because this is a positive 17, so you're going to use a negative for your 3. So when you add them together, you get 17. Okay, and they also multiply to give you negative 60. So I'm going to replace this 17x with 20x minus 3x just to make sure we can factor really nicely. Okay, so we got 4x squared plus 20x minus 3x minus 15 equals 0. Okay, so now I just want to make sure I didn't make a sign mistake here, because I did add 5x to get 17. I did subtract 24 to get negative 15. Okay, we're good. So now I want to factor the first two and the last two. So the first two have 4x in common, so you're going to extract that, and then you're left with x plus 5. The second two have minus 3 in common, so you're going to extract that, and then you're left with x plus 5 here. Pull these GCFs together. You got 4x minus 3 And then you have x plus 5, which is the common factor in both. Set each one equal to 0. 4x minus 3 equals 0. X plus 5 equals 0. So we have x is equal to negative 5, and x is equal to, after you add 3 and divide 4, positive 3/4. So what you want to do is check each one. Anytime you are given a radical problem, and same for rationals, you want to make sure that you check. So if I check, so let's check on the left side 3/4. So I'm going to plug it into the original. So it's going to be 2 times 3/4 equals square root negative 5 times 3/4 plus 24 minus 3. Okay, so 2 times 3/4, you can reduce that down a little bit to get 3/2. And on the right side, we've got a little bit of work to do here. So we got negative 15/4 plus, I can make that 96/4 if I want a common denominator. You can also put this in the calculator. I'm just not using one. So 96 minus 15 is 81. So all of that's under the radical. I don't know why I made my radical so big. There we go. Minus 3. So square root of 81/4. 81 and 4 are perfect squares. So you're left with 9/2. And if I make this a common denominator, 3 will be 6/2. So 9/2 minus 6/2 is 3/2. So that means this is definitely a solution to our radical equation. So now let's take a look at negative 5. So if you plug in negative 5 into the original, you have 2 times negative 5 equals square root negative 5 times negative 5 plus 24 minus 3. And minus 3 is on the outside of the radical. So you end up with negative 10 equals negative 5 times negative 5 is a positive 25. Okay. Then if you reduce what's under the radical, you have 49. 49, square root of 49 is 7. So now you can see that you do not have equal sides there. So it doesn't make a true statement when you plug it into the original. So the only solution we have here is 3/4. So that's your radical example. So now let's take a look at a rational example. Rational just means there's a fraction with some variables in the denominator. So the first thing I want to do is I want to factor my denominator here in order to see all of its parts. So x over x plus 2x minus 2 would be the factorization of x squared minus 4 plus 1 over x plus 2 equals 3. So this is going to help me determine what is the LCD. Now, some people handle this problem differently. Some people like to make them all the same and then cancel them out. Some people like to cancel them from the start. That's me. So I'm going to put this in a different color just to highlight what I'm doing. Okay, so I know my LCD is going to include the common parts x plus 2, but it's also going to include the part x minus 2 because you want to make sure when you multiply every term, it's going to eliminate every single fraction. Okay, so I'm going to multiply by the LCD. Make sure you can see this. Okay, and then over here on the left, it's going to be the same thing. You're going to multiply both sides by the LCD. So now for the first term, that's this term, when you multiply the LCD to that denominator, it's going to divide the entire denominator out. So you're just left with x. When you distribute this, because we just multiplied to this term, we just got x, you're going to distribute to the second term. So the second term has x plus 2 in the denominator. So your LCD, that's written in orange, divides out x plus 2, but you still have x minus 2 left out of the denominator. So you're going to multiply the numerator to what's left in the denominator. So 1 times x minus 2 is just x minus 2. If there was something other than 1, you would distribute that number or that term with whatever's left from the LCD. So now over here on the right, you have 3 times, so we already know this is going to be x squared minus 4 because we factored our first denominator to see all the parts. So distribute and combine like terms. So we have 2x minus 2 equals 3x squared minus 12. You want to move all of your numbers to one side, all of your terms to one side. Since your leading term is already on the right side and we are dealing with equations, it's okay to have everything set on the right instead of on the left. When it's an inequality, it's something different, but I'll wait till I get there. Okay, so we're going to subtract 2x. So if I subtract 2x, I got minus 2x on the right, and if I add 2 to this negative 12, I get a negative 10. So this is our equation that we need to solve for x. Okay, so again, I can test out my discriminant to see if I have a factorable equation. So if you plug in b squared minus 4 times a times c, you end up getting 4 plus 120, which is 124. Not factorable. Okay, so that just means since this is not a perfect square, our equation is not factorable. So we're going to use the quadratic formula. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. So if you plug in, so we already solved for our b squared minus 4ac, so I'm going to place that underneath the radical. But the b is equal to a positive 2, is equal to a negative 2. This negative outside turns it to a positive. So 2 plus or minus square root 124, we just solved for our discriminant, all over 2 times 3. 3 is equal to a. So we're going to have 2 plus or minus square root 124 all over 6. So this 124 does reduce into factors where one of the factors is a perfect square. So if you factor that, you end up getting 4 times 31. Square root of 4 is 2, so 2 comes out, leaving 31 underneath the radical. So you can write this as two different terms, or just recognize this 6 is common with this 2 and this 2. So if you divide 2 out of every single one of those, you get 1, 1, and 3. So your final answer is 1 plus or minus square root 31 all over 3. So if you wanted to check this, you could make sure, as long as your answer is not 2 or negative 2, which those two answers in your original equation would make your denominator 0, you should be fine. If it ever came down to something that you would need to check, I would change this to a decimal just to make my life a little bit easier, and then plug it into your equation just to make sure you get a true statement. Okay? So that concludes the video. If you need any further assistance, please do not hesitate to either email me for making an appointment for student hours, or if you just want to ask me a question via email, or if we can make a phone call with my Google Voice number, whatever you need. One resource that I think would be helpful for all students would be the calcchat.com. I don't know how many people are really using that. I forget to ask in class, but this is a nice website for tutorial help and worked out solutions to odd number exercises in your text. I know we don't do a lot of book work, but you can always practice these as you are learning new concepts. Okay, so this is the conclusion of this video. Have a great day.